Hi everyone. We're going to look at quadratics today. So if you remember back from our polynomials unit, quadratics is a second degree polynomial, which means that there is a squared term in the equation. So the general form of a quadratic equation is ax squared plus bx plus c equals 0. And a and b and c, c is a constant. Okay, a is the coefficient of the squared term, b is the coefficient of the x term, c is your constant. So that's a number without a variable. We're going to look today at trinomial factoring, and we're going to look at trinomial factoring where the a value is equal to 1. So what that means is that we will not have any other constant in front of the squared term other than 1. So you'll see equations that look like x squared plus bx plus c equals 0, and we're going to try to factor those. So let's start here with question number 1. X squared plus 6x plus 5. So we want to factor this. And remember that factoring is reversing the distributive property. So I know that when I think about my factoring, I'm going to be thinking about a term here and a term here and one here and one here. So if I think about my first, outside, inside, last, or foiling like we did before, I know in the binomial that my first terms have to multiply to give me that x squared. And the only way that I'm going to get that is if I place an x and an x there, because x times x is going to give me x squared. So now to see about what to do with the other number. This is our process here. We are going to look for factors of c, which is our constant, whose sum is b, which is the coefficient of our middle term, including the sign. So in this case, we are looking for factors of a 5 that add up to a positive 6. So if I think about writing my factors of 5, the only two factors of 5 are 1 and 5. So they multiply to give me 5, and they add, if I were to add these together, I'm going to get 6. So 1 and 5 are going to be the numbers that I place in here, a 1 and a 5. And because these are both positive, I'm going to have two positives here. So if I wanted to check to make sure that I factored this correctly, I'm going to do my FOIL, or first, outside, inside, last, or just redistribute it back. So x times x is x squared, x times 5 is 5x, plus 1x gives me 6x, and 1 times 5 is 5. So if I multiply that back through, I'm going to get exactly what I started with. So we're going to try a few more examples here. So we have x squared plus 6x plus 8. So following that same process, I am going to be looking for factors of 8 whose sum is a 6. So I'm just going to start writing factors of 8. I know that 1 times 8 gives me 8. 2 times 4 gives me 8, and I think that those are the only factors of 8. So I'm going to be looking at these pairs and trying to figure out the sum that gives me a positive 6, and that would be these two right here. So those are the two numbers that I'm going to use. So when I write my parentheses out, and again, I know that I need an x and an x to give me the x squared, now I have a positive 2 and a positive 4. So plus 2, plus 4, and there we go. If I want to check, x times x gives me x squared, plus 4x plus 2x gives me 6x, and 2 times 4 gives me 8, and so I can call that one factored. Okay, let's look at one that maybe has a few more factors. I'm going to be looking at factors of a positive 60 whose sum is a 19. So I know I can have 1 and 60, I can have 2 and 30, I can have 3 and 20, and so far I'm not really equal to the 19 here. I've got 23, I've got 32, I've got 61, 4 and 15, I think we found it. Okay, if I multiply these together, I'm going to get 60, but if I add them, I'm going to get 19, and that's exactly what I wanted. So factoring, we have our x and our x, and our plus 4 and our plus 15. And you might be asking, could I switch the order? Could I put the 15 here and the 4 here? Yes, you can. Okay, notice how this one has a negative right here. So we're still going to follow the same process, only this time I'm looking for factors of a 48 whose sum is a negative 19. So I'm going to just write that here. Sum is a negative 19 over here. The sum was a positive 19. All right, so let's think about our factors. We have 1 and 48. We have 2 and 24. And I guess I should also think about, let's see, this has to be a negative 48, so, or a negative 19. So 1 and 48, 2 and 24, negative 1, negative 48, negative 2 and negative 24. So we have 3 and 16 and negative 3 and negative 16, and I think these are going to be the pair that we want. So negative 3 and negative 16 are going to add up to be a negative 19, and so this is the pair that we want. So when we write our factoring, I have my x and my x, a negative 3 and a negative 16 here. So just checking it, x times x gives me x squared, x times negative 16 gives me negative 19, and negative 16, and then negative 3x is negative 19, negative 3 times negative 16 is a positive 48. So I think I'm good with that. So next one, I am going to be looking for factors of a negative 30 whose sum is a negative 13. So because I have a negative here for this last term, I'm going to have signs that are opposite. So I could have 1 and negative 30, negative 1 and positive 30. I could have 2 and negative 15, and negative 2 and a positive 15. And there are others. We can also have 5 and negative 6, and we can have negative 5, positive 6, and I guess 3 and 10. So 3 and negative 10, negative 3 and positive 10. So I'm looking for the pair that gives me a sum of negative 13. And I think if we come to this one right here, 2 plus a negative 15 is a negative 13. So I'm going to write my binomials with the x, and I have a plus 2 and a negative 15, and then we can call that one done. And again, you can check it by multiplying back through. So x times x gives me x squared minus 15x plus 2x gives me negative 13x, and 2 times negative 15 is negative 30. So we need to be careful with the signs if you see negatives like in these last two examples. So that's it. Bye guys.